supplemental. Still working on that Genrad 1390B to convert it into an amplifier. Take it from a piece of junk into something that can be used for 50 years to come. But then there are some that wonder why I'm doing this. Why would I take something like this and turn it into that? My question to you is, why? So it's time to wire our repurpose amp project. I'll go over the controls again. This knob is still the output, so this will be the sensitivity for the meter, which is going to watch the voltage across the speaker output jack. This one is volume. Here is your input jack for the guitar to plug into. Bass and treble controls. And these are old vintage 50s Bakelite knobs. We're going to reuse the power switch, and we have a GE47 power lamp. Let's go around the back and take a look at the chassis. Here's the chassis. Got our power transformer. This is the pot for the sensitivity. This is your volume pot, input jack for the guitar, 12AX7 preamp, output transformer, which is a triad, and there is the output jack, and this time it's going to be wired for 4 ohms. Got our pair of original 6AQ5s, 6AV6 inverter tube, filter cap. I've already landed some terminal boards. I'm going to try to do this build with as few terminal boards as possible. Keep this a true point-to-point wired amp. This was the original rectifier board. You can see the power transformer is already landed. So this is our 6-volt filaments. My high voltage here going to the diodes, power switch, indicator lamp. So first I'm going to construct the power supply. So I'm going to hook up all the filament lines to the tube sockets. Then I'll hook up the high voltage and we'll put a load on it, fire this thing up, and see what our high voltage is with an assumed load of, say, 40 milliamps. So let's get wiring. So as I showed you in part 1, we do have a schematic to go by, and this schematic I've utilized many times in the past on different amps, so I know this is a good circuit. Alright, so we're going to start out with the filament wiring. Easy way to get your wires twisted is use a drill. So this is a 20 gauge wire. Twist it. Get them in place. At this stage we do not have the high voltage connected. I just want to see if we have any life and make sure there's no shorts. So I'm bringing up the variac. You can see my high voltage coming up. And when we kill the lights, we'll see if we have tube filaments. Well, there's a happy light. Kind of looks like Rudolph's nose, doesn't it? If you look inside, you can see we have filaments on the tubes. So the 6-volt AC filament lines are complete. Now let's do the high voltage. Our high voltage wiring is complete. So here is my AC. It goes through the diodes. This lead goes up here to the first section of the filter cap, over here to the primary side of the output transformer, so that's the center tap. Then we go through this 1K resistor, and then this cap is for the screens, right? So that goes over here to pin 6 of both of the 6AQ5 tubes. Then from there we go through a 22K, and if you follow this lead over, it goes to another cap, and this will end up feeding our inverter and the 12AX7. So what I'm going to do is apply a load. We're going to bring it up and see what our high voltage is. So for the initial test, I have removed the output tubes. So the high voltage isn't going anywhere except for the filter caps and my load resistor, which in this case I chose a 15K ohm. So I'm going to assume we'd see about 350 volts. So if we divide that by 15K, be about 23 milliamps of current, which is just fine for testing. I just want to make sure that the power supply is working and see what that high voltage turns out to be. All right, here we go. Into the load resistor. I'm going to bring it up on a variac. Watch our high voltage. 90 volts. I'm at 50 volts input right there. Take it up to 100. No smoke out of the resistor yet, that's good. Okay, there is 100 volts applied. You can see we're right around 327 volts. Alright, so I'm going to turn it down, and at this point, I'm going to plug it right in the wall. Okay, yes, there's fuses installed. I just want to see what full voltage is, and look at there. About 385 volts. This is going to be a pretty powerful little 6AQ5 amp. So power supply is check out. It's time to install the rest of the components. There's not much left to do. We're going to have the same plan. Alright, all the new components are installed. So let me get my scope and an audio generator. Let's fire this thing up, see what the sine wave looks like. So before I hook up the scope and show you the output, I just wanted to point out there were some changes to the schematic. I put in a different output transformer. The little Hammond was only good for about 8 watts of power, whereas this big old Triad can handle 10. And then we have the output jack here, which is only 4 ohms. So I'll show those changes on the schematic. All right, here we go. Initial test. I got quite the stack up of equipment. Leader audio generator, D-Lab audio test set, and the oscillating television. We're going to inject into the amp, monitor it on the Scoperino, and you get to watch the output meter work. So remember, this is bass, treble, volume, and this is my output sensitivity for the meter. Okay, so here we go. Bringing up the signal. What do we got on the scope? Whammo bammo. Okay, here is my treble. Look at that sine wave, crystal clear. Look at that meter. Oh, that's going to be wild when you're playing your guitar. This thing is really turning out to be a great project. Alright, secret surprise time. I'm sure some of you spotted this additional octal socket on the chassis. You're probably like, what's D-Lab up to? Yes, I have made a revision because some of you wrote in and said, man, why do you have a tube amp with only diode rectification? So here's what we're going to do. I have this beautiful Sylvania 6X5 rectum fire tube, and he will plug into that socket. And then the output adjustment we are going to change with this ceramic switch. This switch was originally in the Genrad. Okay, so now we're going to use this switch as a diode or tube rectum fire switch. Okay, and then our meter adjustment, the sensitivity adjust, now will swing over here. There was already a hole here, so I figured, alright, you know, you're probably not going to be twiddling this knob that much. So let's get him over here and let's put some more functionality on this amp. So now you'll have tube rectifier versus diode. So let me install that and we will retest. I've made the updates. Now, instead of the sensitivity being here, we have the tube or diode select position, and over there we got the sensitivity. Let's power it up. Watch the tubes glow. The new 6X5 is installed. Okay, let's give her a test. All right, we're in tube mode. There's my volume. You can see our meter responding. Now if I reach over here, I can adjust the sensitivity of the output meter. Okay, so like I say, we're in tube mode. There's a sine wave. I'm going to switch over to diode. You can see a slight increase in amplitude. So that's pretty much it. Tube rectifier. Diode rectifier. So now obviously we need to put some music into this thing so you can see the output meter respond appropriately. I'm pretty sure it's kind of a very cool effect. We have our new output select switch. Beautiful old ceramic switch that was originally in this instrument, being repurposed as the tube diode mode switch. Very cool. Here is the sensitivity pot. Okay, and that comes off of a little 1N403 diode that's tapping right off of the 4 ohm speaker output through that vintage triad output transformer. The beautiful old Sylvania 6AQ5 is doing the job, and now a 6X5 rectifier. Let's go underside real quick and take a look at the final wiring. So there it is. Here is our new rectifier tube, the 6X5. So pins 3 and 5 actually are connected direct to the high voltage that is also feeding the diodes, okay? So the output of the diodes and the output of the tube go through the switch and they come back to the filter cap, okay? So that's how you select either tube or diode rectifier mode. The rest of the amp remained unchanged. Here it is, as promised, the updated schematic for the little Genrad 6AQ5 push-pull amp. This schematic now shows the rectifier select switch with a 6X5 rectifier tube. A very needed addition to this amp. So now you can get that cool tube rectifier sound, or you can get a little more of a punchy diode sound. If you guys want a copy of this schematic, just email me and I will send you the JPEG. Thanks for tuning in, guys. Let's see how this thing sounds. So in case you're wondering, what was our final high voltage tube mode versus diode mode? So right now I'm in tube mode. You can see we're at 333 volts applied to the plates of the 6AQ5s. Now I'm going to go to diode mode. Jumps up to about 368. Alright, so Tony's playing the Genrad pair of 6AQ5s built in the old General Radio test equipment cabinet. You know what people are calling me now, Tony? Destroyer of vintage test equipment.
Destroyer. Here we are, and he's and we're socially distancing ourselves from the rest of the guitar world.
That's right. Alright, so you can see that this amp project really turned into something out of this world. However, there are some of you that have asked me, how could we have avoided taking this piece of history and turning it into something that's useful for another 50 years? Okay, I'm going to give you a really simple solution. You need to find yourself a star-class ship capable of, let's say, at least warp 1. You have to exceed the speed of light. Then you're going to slingshot around the sun. You're going to come back to Earth in, say, 1995, around June 15th, when I was at the Chelsea swap meet, okay? You need to get there at least 5 minutes before I go up to the table and buy this thing with the intentions of converting it into an amplifier. Then you can put it on your shelf and admire it and say, this will never become a guitar amp. How's that?